Now we continue further. We will go through few more instructions and we will go through the use of those instructions for programming. Now 8085 is 8-bit processor, but it allows some 16-bit operations to be carried out as an exception by using some remaining combinations of the what we can say opco. So means 8085 is a 8-bit processor, but some 16-bit operation means it allows few instructions which handle 16 bits of data at a stretch. Otherwise, without using these instructions, same task can be performed by doing the things repeatedly. So just to provide some ease of programming, make it to make programs more compact, some 16-bit instructions are there which I would like to list. Number one is that now we go through all different instructions. Say some are data transfer, some are arithmetic logic. So in general now I am sure that you are well equipped with the overall instruction set. So there is no question of this instruction or that instruction. So now by the end of next week we wish that around 90% instructions should be completed. Few are there which will require some time, but about 90% instructions, the moment at which the instruction is given, everything should be absolutely clear for everybody. So the next is DAR-H. We had already discussed this instruction. DAR-H is a 16-bit addition instruction provided specifically for 8085 to perform the task of 16-bit addition at once. So this is double addition. Again, that as I had stated, that there is no specific rule. It's just like WhatsApp grammar. There is no specific rule for how the short form of the instruction should be. So for add ADD, for move MOV, so for load LDA, like that. So DAD means it's double addition. DAD-H. So not DAD-H. I mean that is the instruction, but DAD-H is one of the instructions. But in general, it should not be started with DAD-H. So the instruction is DAD, double addition. So when we say double addition, DAD-H we took because what was in our mind? That the multiple problem was in our mind. So I took that instruction directly. So the instruction is DAD, double addition. So obviously what we will need? Two 16-bit operands to be added, and how much bit destination? 17-bit destination. Two 16-bit source operands and one 17-bit destination operand should be provided. Now there is no point in asking you what you will do because it is all done by 8085 designers. So the 8085 designers have provided a provision or made a provision for these 16-bit additional operands as follows. That they have provided HL, that is H and L register pair, as the default, one of the default sources as well as the default destination for lower 2 bytes. So HL is one of the sources as well as destination. HL is getting assigned to HL plus a register pair and obviously carry flag. Is it clear? मराठीत सांगतो. DAD ही डबल ॲडिशन इन्स्ट्रक्शन आहे की ज्यामध्ये ॲड मध्ये कसा ॲक्युम्युलेटर होता तसा फक्त DAD करता HL हा 16 बिट ॲक्युम्युलेटर सारखा वापरला जातो की ज्यामध्ये तो डेस्टिनेशन देखील आहे, तो वन ऑफ दी सोर्सेस देखील आहे, आणखी एक दुसरा सोर्स की रजिस्टर पेअर स्पेसिफाय करायचा असतो आणि 17 बिट कॅरी आहे. सो carry and HL pair is a 17-bit destination for add instruction to store the result, and the source operands are HL and one of the register pairs. So how many register pairs are there? BC, DE, HL itself, and stack program counter is a but it is not, it has program counter is having a very specific purpose, so it is not covered here. So the register pairs covered for DAD instruction are BC, DE, HL and SP. So there are, so just like how many add instructions were there? 8 add instructions were there. Like that, how many DAD will be there? 4 DAD. So DAD B, DAD D, DAD H and DAD S. Is it clear? So B means BC, D means, because it is double. We don't say DAD BC. DAD B means B and C. DAD D means D and D. With B higher byte, C lower byte. DAD H means H and L, and SP is a pair itself. So SP is having a pair existence. Individual part of SP is not accessible. Listen very carefully. BC, DE, HL are individually accessible in normal instruction as general purpose register, and these are accessible as a pair in some specific instructions. Whereas stack pointer is having a specific purpose, to that we shall come later. Its individual components are not separately accessible. So it is to be addressed just like stack pointer and program counter are applied as a pair only. So these are 4 instructions, right? Is it clear? And the result is contained in HL and carry flag. DAD H. Oh, so DAD instruction, DAD. One. Then there is one more instruction, there are few more instructions, not one. That when we want to initialize, when we want to initialize some registers, we use the instructions, say MVI, means in instruction set, when we say data transfer, in that when we want to initialize, we use immediate addressing mode. So MVI A, MVI B, like that there are 8 move immediate instructions. Then merely because some space was available in the design of instruction set, and to make the things somewhat simpler, means it doesn't bring much value, only 1 byte is reduced while programming, that the register pairs BC, DE and HL are also allowed to be initialized as a pair, and for SP it must be there because it's individually not accessible. So there are few instructions, LXI, load register pair, then YX, there is no meaning, no logical justification. So somehow say, the full form is load register, for move, it was move immediately within the register. So it is YX, MVI, अगदी असं तुमच्या एखादा अगदी किस पडणार आहे, पण सध्या MVI का म्हणलं नाही, MVI चाललं असतं ना, पण मग आता MVI म्हणलं की मग तिथं BC म्हणायला लागलं असतं किंवा D म्हणायला लागलं असतं. त्याचं लॉजिक असं आहे काय हे माहित नाही, म्हणजे त्याला काय लॉजिक नाही. मग त्यापेक्षा MVI BC म्हणलं असं चाललं असतं, पण BC मध्ये B म्हणतात, C अज्युम्ड आहे म्हणून, आणि ते जमली होऊ नये म्हणून हे L, लोड register pair LXI RP data 16. The instruction format is LXI RP, where RP means either B, that is BC, DE, HL, SP. So LXI B, LXI D, LXI H, LXI SP are 4 instructions. Each of them is 3 byte long, and it takes how many machine cycles, that I would like to know from you. When we consider all there are few more instructions which I will describe, and all instructions we shall use simultaneously. I hope now that register set is very clear to you, memory organization is very clear to you, so that now learning of instructions should be a high school, not even NTS preliminary I will say. Learning of instructions after this idea is a high school scholarship level task, so that there should not be any scope for not understanding it. Neither you can afford to not understand it, right? So LXI, DAD, And a few more. In the data transfer instructions, various ways are there: immediate, register, register indirect, like move A comma M, move A comma M, where address is indirectly specified in HL pair, or LDA, direct address specified. So more and more options you provide, it becomes somewhat rich, instruction set becomes rich. Like that, to provide for 16-bit operations, two more instructions are provided, which allow, means what LDA does. LDA allows me to bring the data from external memory location whose address is specified in the instruction. So destination is register, that is accumulator, and source addressing mode is direct, means the address of the source operand which is in the memory is given directly in the instruction, direct addressing, LDA. Like that, to allow some 16-bit operations, HL is as good as is considered as a 16-bit accumulator, and some instructions to, means remember the instructions which we are learning from DAD are additional, means these are not basic, means even if these instructions were not there, the things could have been arranged by using the available instructions many times. Whether anybody of you has completed a program of addition of two 16-bit number without using ADC? Last time we discussed 16-bit addition. For that we used ADC, add with carry, while adding the higher byte. Whether, and it was told that you should complete the program without using ADC. Have you done that? Okay. So these instructions are there which help to make the program compact, but these are not essential. So like that, what they have provided, a facility to load this 16-bit register pair HL, which is used as, which is called as 16-bit accumulator for some operations, from memory directly. The instruction means an instruction similar to LDA. LDA चा फॉर्मेट काय आहे? LDA address 16 means the accumulator is loaded with the contents of the external memory location whose address is given in the instruction itself. Like that, a 16-bit directly addressing mode loading from memory. So for that purpose, the instruction is LHLD, load HL pair directly from. The format is address 16. Load HL pair directly from. The format is LHLD address 16. So example, LHLD 5000, what it will mean? LHLD 5000? The contents of the external memory location 5000 will be brought to memory locations. किती bits है? 16 bits है? 8 bit. HL कितनी bits है? 16 bits. So can you complete the sentence? The contents of external memory whose address is 5000 are brought to L register, and contents of next location. When I remember, even if you go for Pentium today or the further processor of Intel, the one location of 8 bits only. That is a byte. What is a word? 2 bytes. What is a double word? 4 bytes. So when I say that I will bring a word from external memory inside, a word means location at given address and next location, which means what is the meaning of bringing a 16-bit value. When we become experts, we are used to this convention. I will say that LHLD instruction will bring a 16-bit data from external memory from the address 5000. That too it is wrong, but when everybody knows what it is assumed that bringing a 16-bit value from memory means bringing an 8-bit value from address 5000 and bringing next higher byte of 8 bits from the address 5001. Is it clear? Is it okay? Load H and L directly from. Likewise, there is another exact complement. Store H and L directly to. Store H and L directly at. Store H and L directly at. Right. So these, what we are doing, I am explaining various instructions. Then you are expected to think how it will progress, type, address, data. It's machine cycles you must be able to write. And if you are not able to write, we will elaborate again. So what additional step we have studied? DAD, LXI, LHLD, SHLD. So when 8085 was at its peak 3 decades back or 3 decades back, a typical question in oral examination was, there is one more instruction called as LXI, if you studied, LXI RP, out of that LXI H. LXI RP at least LXI H, what is the format? Data 16, and the examiners always used to ask, what is the difference between LXI and LHL? So LXI H is immediate addressing mode. What to be put into HL is provided in the instruction that goes to HL. Whereas LHLD is direct addressing mode. Whatever is in the instruction is used as an address and contents of memory location at this address and next address are brought to HL. So this is a very typical one, and normally around 40% people used to jumble. In 2022, such jumbling is not what we can say affordable to us. So these DAD, LXI, LHLD, SHLD. Now there are 2 more instructions provided, that when I want to bring data from external memory inside the processor, I can bring it by many ways. LD I can bring, move A comma M I can bring, 16-bit LHLD I can bring. Now there is one more instruction, and now today I am, see, if you are used to very simple thing always, then you will be finding it a troublesome situation which we faced just now at the beginning of the lecture. So slowly we must raise the bar. So I am bombarding with the instructions, explaining it in simple language. It is expected that now no need to ask from where should I search. On Google you can give, immediately you get the contents. So the next instruction is LD, listen now, LDAX RP. LD LDAX register pair. So the instruction is, listen very carefully, it is indirect mode for the source and destination accumulator. The full form आहे आणि हे काय तुम्हाला माहित असण्याची गरज नाही, कारण कुठल्या ना कुठल्या पद्धतीने सिंटॅक्स केला असतो. तो मी 85 ने काय केलं तो सांगायचा तुम्हाला कळला पाहिजे. इट इज लोड LDA झालं. कसं आता हे लोड accumulator from the memory whose address is given in the given register pair. So the examples are, it is register pair. So LDAXB, what this will do? So LDAXB will bring the contents of external memory location into accumulator whose address is given in BC pair. So how many bytes this instruction will be? LDAXB is 1 byte. And how many machine cycles it will need? At least first it will need to bring the instruction and 1 or 2. So LDAXB bring the contents of the external memory location whose for which BC pair acts as an address. For which BC pair acts as an address. What will happen? How many machine cycles? 2 or 3. LDAXC now you must be able to think. आता मी इन्स्ट्रक्शन काय तुम्हाला विचारलं नाही, कारण ते काय माहित असणं अपेक्षित नाही, पण काय सांगितल्यानंतर मशीन सायकल कळले पाहिजे. LDA परत सांगतो, LDAXB load accumulator from external memory location for which BC pair acts as an address. For which BC pair acts as an address. काय पाहिजे? कसं किती माहिती? नंबर ऑफ बाइट्स 1. LDAXB चा ऑपकोड 0A आहे सर. 0A opcode is, you can confirm that right now. I recollected it to be 0A. So 0A load accumulator from external memory whose address is in BC pair. So okay, so this is very important. So I take a break in the sense, not for the lecture, break in, explain the instructions, and we deal with this instruction right now. So type obviously opcode fetch. Address obviously program continuity. Let it be anything now. So that is not a particular 0 or anything it can be. So let it be 1000. Data is 0A. That goes to instruction register. So when 0A goes to instruction register, 8085 has understood the instruction LDAXB. LDAXB happens to be the instruction which would like to bring the data from external memory whose address is in, I forgot that it was not working yesterday, it's working now. And since we are to continue again for one next session as well, for which you must be very much
what we can say, upset. In order to enable me to speak for continuous time, we have misassigned me. So LDXB is understood by 85 completely. What next? What should happen now? The instruction requires the microprocessor to bring the contents of an external memory location into accumulator. So operand is external. Therefore, for execution only additional machine cycle is needed. So what now the speed with which the speed with which I am explaining, you might be aware that now it is stopped. You may ask your parents. There was a concept of slow speed English bulletin. 25 वर्षापूर्वी 2 वाजता इंग्लिश न्यूज असायच्या, टीव्ही वगैरे नव्हत्या. 30 वर्षापूर्वी 2:10 हिंदी बातम्या असायच्या आणि 2 ते 2:10 जे इंग्लिश बातम्या सांगायचे तेच 2:20 ते 2:40 मध्ये त्याच कंटेंट सांगायचे. म्हणजे जे इंग्लिश शिकत होते ते आधी 2च्या बातम्या ऐकायचे पहिल्यांदा, मग हिंदी बातम्या ऐकायचे आणि मग पुन्हा 2:20 ते 2:20 जे 10 मिनिटात सांगायचे ते स्लो स्पीड मध्ये 20 मिनिटात सांगायचे. तसंच आता जे मी सांगतोय स्लो स्पीड इंग्लिश बुलेटिन म्हणायचे, म्हणजे जेणेकरून न्यू इंग्लिश लर्नर जे त्यांना ते कळेल. आता हे स्लो स्पीड इंग्लिश बुलेटिन आहे. सो an additional machine cycle is needed. For that additional machine cycle, it would be other read OR. Who will provide the address? BC pair will provide the address. Let that be 7,000. Let the data be 44, and that will go to accumulator. Right? Is it okay? So it is LDXB. Similarly, there is LDXB. Means other than except B, it would be B. Other than it will be not be BC pair, it will be D pair, and there will be LDXH. So LDXH, what it will do? It will. Can you explain? LDXH bring the contents of external memory location into accumulator whose address is given in HL pair. So LDXH, you can now, the task is for you after the lecture to search the opcode for LDXH, or we can take a break. You can break up 2 minutes. You can on Google, you can search the opcode of, just give opcode of LDXH and tell me what that is. What is the answer? LDXH opcode आहे का? LDXB चा D चा आहे. आता कारण का नसेल एक साधारण अंदाज येईल. इन्स्ट्रक्शन आहे का ती? LDXH आहे का? का नसेल? अंदाज? Right, somebody is getting the thing. What is that?
Equivalent is move a comma.
So LDXH instruction is not needed. LDXB, LDXD are needed because the HL pair actually, when we studied the earlier instructions, move RD, RS, that time the designers have provided that the M is a virtualized register, means an external memory location whose address is given in HL pair can be used for all operations for which register is used. So the instruction to bring the contents of external memory location whose address is given in HL pair into accumulator is already there in move A, M. So HL register can be used for wide range or variety of instructions which deal with the data stored in the memory at a location whose address is in HL pair. So this would be redundancy. So there are only two instructions. This RP is used either B or D, no other. LDXB and LDXD, and similarly, what would be the counterparts of LDX? STAX, STAXB and STAXD. So STAXB is store accumulator in the memory for which registered DC pair gives the address or acts as an address. Now, in the next weekend means what we will do, by next weekend, everybody of you must be able to understand and write the machine cycle sequence for every instruction. प्रत्येकाला प्रत्येक मशीन सायकलचा इन्स्ट्रक्शन सिक्वेन्स लिहिता आला पाहिजे. दॅट इज क्वेश्चन बँक. ते आलं तर मग काय प्रश्न निर्माण. 246 जरी आपण पॅन्डेमिक संपलं असतं तर 246 इन्स्ट्रक्शनची क्वेश्चन बँक आहे. त्यातलं परीक्षा येणार. प्रत्येक आपलं सगळं झालं पाहिजे आणि येत नसेल तर रिव्हिजन. Is it okay? LDX. Then we move on next group of instructions. Now you will find that we have studied the instruction like jump on no carry, because carry is coming in arithmetic operation and we have to make arrangements for storing the higher byte, either 0 or 1, for which we use the conditional instruction of jump on carry or jump on no carry. Like that, since now you are students of computer science, loop concept is well aware, we are well aware with the loop concept. So when you are well aware of the loop concept, there should be some way of implementing a counter and executing a set of instructions repeated times depending upon the counter. लक्षात आलं का? तुम्ही मागच्या वर्षी शिकला असाल, हे आता खूप अगदी ऑब्वियस आहे की एक ग्रुप ऑफ इन्स्ट्रक्शन सारखा बऱ्याचदा एक्झिक्यूट करत असतो. किती वेळा ते सांगितलं असतं, 10 वेळा एक्झिक्यूट करा. ओके, नाउ I would like to explain it in very simple way. Suppose if that you have to look at this smartboard and listen to me, even if you may or may not understand. Suppose if something is to be done repeated number of times. So for what purpose right now we are not bothered. So these are the sequence of instructions I will repeat. So what is the obvious way? I want means I want now the ragging is obsolete, means it doesn't take place almost anywhere. But some kinds of say that what you do, that bucket, a spoon, have the water from one bucket to other bucket, or this one. Lift this pen, put this pen down. Lift this pen, put this pen down. Some is to be done repeatedly. So like that, what is the obvious way? Some instructions are there, and we just like the seniors make the while writing junior to do some. Then what is any purpose? No, just to tease that this is to be done. So like that, you want microprocessor to execute a group of instructions number of times. So what will you do? There is simple obvious way. What is that? Write it continuously. Repeat. You write the instruction in memory. Repeat the instructions, actual instructions again and again. So that would be achieving the purpose, but that would be very, what we can say, non-smart way. We say donkey work. Now if it is to be done in smart way, what is done is that we take help of the concept of counter. So we initialize counter. Counter is initialized here, right? Counter is decrement counter. Then what we do? What we do here? What we do? We check whether counter has become. लक्षात आहे ना? मराठीत सांगतो. एक 10 इन्स्ट्रक्शन सारखं मला तेच करायचंय. मला असं पाहिजे आहे की मायक्रोप्रोसेसरनं त्या 10 इन्स्ट्रक्शन सारख्या एक्झिक्यूट केल्या पाहिजे 10 वेळा ते 15 वेळा. Hello. I want microprocessor to execute a group of instruction repeat number of times. So I can repeat it as I want, but that would be a non-smart way. So what I will do, I will initialize the counter, some counter by a value for which I want this to repeat. Once it is done, I will decrement the counter, and then what I will do? After decrementing the counter, what I will do? Anybody? Check whether the counter has reached 0. If the counter has reached 0, if the counter has not reached 0, what is to be done? I will repeat. Decrement counter here equal to 0. What I will do after decrementing, I will check equal to 0. If no, what I will do? And if yes, I will come out. Is it right? So you need some instructions which allow these two things. That is decrementing a counter and one instruction which will branch if condition is fulfilled or not fulfilled. There may be two options: jump on something or jump not on something. There's a jump on carry or jump on no carry. Means the conditional branch instruction branches depending upon either fulfilling of condition or not fulfilling of condition. If it branches, it goes to address providing the instruction. If it doesn't branch, it comes to next instruction. Is the idea clear? So we want decrement operation. Now say that now here I would like to explain something which is of somewhat complex level, because if you are, I again repeat, if you are used to simple things, your ability to deal with complex situation would be reduced. We don't want that to get reduced. That the instruction for this we have already discussed, that is jump on no zero. Means what? In the flag register there was one carry flag. One bit was there for carry flag. Likewise, there is one bit for zero flag. What then happens? Listen very carefully. If the result of any arithmetic or logic instruction is zero, zero flag becomes 1. And if the result of arithmetic or logic instruction is not zero, zero flag becomes 0. लक्षात आलं? म्हणजे एखाद्या अरिथमेटिक किंवा लॉजिक इन्स्ट्रक्शनचा रिझल्ट 0 असेल तर 0 फ्लॅग 1 होतो किंवा त्याला आपण 0 फ्लॅग सेट होतो असं म्हणतो. आणि अरिथमेटिक आणि लॉजिक इन्स्ट्रक्शनचा रिझल्ट जर 0 नसेल तर 0 फ्लॅग 0 होतो किंवा त्याला आपण 0 फ्लॅग रिसेट होतो म्हणतो. प्रत्येक आफ्टर at least other flags we will discuss later. Zero and carry flags are affected after every arithmetic or logic instruction. प्रत्येक arithmetic किंवा logic instruction नंतर हे flags affect होतात and they provide the status of these two conditions when the last arithmetic or logic instruction was executed. Data transfer instructions flag affect करत नाही. Now decrement करता instruction आपण शिकलो, पण ती आपण असं म्हणू की तुम्हाला न कळण्याच्या स्टेट मध्ये होतं म्हणून ती आपण शिकून असं समजूया आणि पुन्हा शिकूया. तर आतापर्यंत तुम्ही ज्या शिकलेल्या इन्स्ट्रक्शन्स आहेत त्या वापरून तुम्हाला डिक्रिमेंटिंग करता येईल का? बघा आता, I want very focused attention. We want to develop a program to transfer. We want to develop a program, or that program we shall discuss later. We want some instructions to repeat, and after that the counter should be decremented. So let us use accumulate as the counter, right? Listen very carefully. So MVIA 05. Then these are some instructions. Say you might be knowing delay program, right? Which you are well aware with. आपण काय म्हणजे delay म्हणजे काहीच करायचं नाही, वेळ काढायचा की जे आपण करतो. So in delay program what is there? Knock. So we can have few knock instructions. Knock. हेच करायचं मला, बाकी करायचं नाही मला. आणि हे काय करायचंय मला? हे ह्या 5 इन्स्ट्रक्शन आहेत ना, इथे 6 येतो. MVI 06 आणि या 5 नॉक इन्स्ट्रक्शनला 6 वेळा एक्झिक्यूट करायचे. मग मी काय करणार इथं? जम्प ऑन नो झिरो बॅक इथं. आणि आता इथं तुम्ही शिकलेल्या, तुम्ही शिकलेले नाही, मी वर्गात सांगितलं, कारण तुम्ही बऱ्याच शिकले असाल नंतर मी सोडून, बरोबर? मी वर्गात सांगितलेली इन्स्ट्रक्शन वापरायची की जेणेकरून बघा मी किती इतकं सोपं सांगायला लागलं की तुम्हाला द्यायला पाहिजे. मी वर्गात शिकवलेली इन्स्ट्रक्शन वापरायची की जेणेकरून ऍक्टिव्हिटी 6 असला, म्हणजे वर्गात शिकवून म्हणजे मराठीत सुरू केल्यापासून, ते म्हणजे तुमच्या सोपं शिकवायला लागल्यापासून, आधीच नाही. मी वर्गात शिकवलेली इन्स्ट्रक्शन घ्यायची की जेणेकरून ऍक्युम्युलेटर 6 असला 5 झाला पाहिजे, 5 असला 4 झाला पाहिजे, 4 असला 3 झाला पाहिजे. डिक्रिमेंट वापरायची नाही. म्हटलं भाऊ किती? Anybody else?
Move है?
Move FF to B and then add B.
Very nice, but can you do it again in more simple way? The answer is great. Anybody else? Anybody else? Okay. Let us go by reverse switching as he has said. ADIFF. Add immediately FF. What will happen?
1F5.
So ADIFF will make it, as he said, 105. That is, carry flag will become 1 and accumulator will become 05. Then again we do ADIFF 4 like that. So when accumulator has become 01 and then if I do ADIFF, what will happen? Accumulator will become 0 and carry will become 1. But accumulator has become 0. So 0 flag will set. Is it clear? So effectively ADIFF instruction is equivalent to which instruction? Decrement A. And increment by काय? It is simple, ADI 0. So ADI 01 and ADIFF act as increment and decrement A instructions, but the problem is that हे आता A मध्ये B मध्ये काय असतं चालेल का? सो ADI वापरून करत असेल किंवा decrement or increment तर only A I can use but not other registers. But it can be done. जर का other register असतील तर काय करायला लागेल? B register वापरायचा आहे. B register म्हणजे काउंटर आहे. हा काउंट मला ह्याच्यामध्ये मला A लागणार कुठेतरी, त्यामुळे काउंटर मध्ये मला B मध्ये टाकायचं. मग काय करायला लागेल? काउंटर B मध्ये असेल तर काय करायला लागेल? काउंटर B मध्ये आहे तरी मला डिक्रिमेंट करायचं आहे. डिक्रिमेंट B करायचं आहे मला ऍड वापरून. कसं करणार? मूव कसं करणार? मूव A, B, ADIFF, मूव B, A. Clear? लक्षात आलं का? So these are the ways with which we can do something without using the specific instruction I am already here. But now means this will make the instruction set too compact and programming skills required would be much higher. And also program will become bulkier. Therefore, obviously, the microprocessor हा तुमचे प्रोग्रामिंग स्किल्स हे किती चांगले आहेत याच्याकरता केलेलं नाही, तर इन जनरल काम सोपं करण्याकरता केलेलं आहे. Therefore, the instruction set designers have provided the following instructions. Number 1, INR, DCR, INXRP, DCXRP, RP, jump on 0 and jump on no 0. Here R means A, B, C, D, E, H, L and M also. M also. Here RP means BC, DE, HL, SP. And jump on 0, jump on no 0. Jump on 0, jump on no 0. Is it clear? So this especially increment is not that way required, but decrement is required for loop instructions. Decrement is required for loop instructions. Is it clear? So this is the additional set of instructions. So many instructions we have studied today in the first part. Now we shall go for what? Machine cycle sequence for each of these instructions. We go for machine cycle sequence of each of these instructions. So what we studied first? DAG. So all we will cover. And there is one more very simple instruction. It is XCHG. There is one more instruction, XCHG, exchange. It exchanges D, it is unique. It exchanges D pair and HL pair. Exchange exchanges D pair and HL pair. So that is very simple. Just म्हणजे आधी आहे म्हणून सांगायला लागते. बाकी काय तसं त्यामुळे फारसं वेगळं असं काही नाहीये. It exchanges D pair and HL pair. Now what we will do? We will do some programming and we will study the machine cycle sequence for all the instructions which we have studied just before. So one simple programming example which we already discussed using add, but now we will use dad. So the program is and one more which again we have discussed, but today I will again refer so that is also used. Rotate accumulator. Rotate accumulator either right or left. Rotate accumulator either right or left. And there are two types again. RAL and R and RAR, and there is one more RLC and RRC. Now I think that म्हणजे आता हे अवघड वाटलं म्हणून मी थांबणार होतो, पण अवघड वाटून थांबायची तर गरज नाही. Rotate these are two instructions.